Hi everyone, my name is Eric and I'm a senior majoring in IE and Stats. Today for my 5-minute tutorial, I'm just going to do a quick demonstration of how to make a data visualization and train a machine learning model in R. So I chose this topic, I chose to do a demonstration because I knew that there would be a wide variety of levels of experience with R in this class. So it's my hope that if you haven't used R before, that seeing a quick demo will give you an idea of what you can do with this really popular statistical programming language. And if you have used R, hopefully I've chosen some things that you haven't seen before and you can pick something out from this too. So, just to introduce our dataset comes from this website called Driven Data. And it's this really cool platform for data science competitions that have some sort of humanitarian theme to them. So this one in particular is from the Tanzanian Ministry of Water. And it's this data set about all the water pumps in Tanzania, and the goal of this competition is to train a model that will predict whether the pump is working or if it's not. So let's take a quick look at the data set. So I've loaded this data into R, with full disclosure that I slightly modified it for this demonstration. But you can see the data set here, and so each row in the data set represents a water pump. And it tells you if the pump is functional or if it's non-functional. It also gives you this information about, like what year was the pump constructed in, all this information about the pump. It also gives you longitude and latitude, so that makes this actually a geospatial data set. And so I'm going to start the process of analyzing this data by plotting it. So we're going to visualize this with a package called ggplot2. And so if you have used R before and you've only ever used the base plotting package, I would highly recommend you look into ggplot2. It's an incredibly cool package that is more popular and more powerful than the base plotting package. So just to demonstrate, let's start by plotting the location of all the pumps. And this is a kind of plot that you can definitely do in Tableau or in Excel or in ArcGIS. But it's nice to be able to do this in R if you're doing statistical analysis, to keep it all in one place. And there's also capabilities of this that you don't get in a software like Excel. So here we go. Here's our first plot. What I've done here is I've initialized the plot using a command called ggplot and added a layer to it. Geometry point is pretty much a scatter plot, and I've set the x-axis to equal longitude and the y-axis to equal latitude. So what's kind of cool is at this point, if you look at the shape of this graph, you can see if I pull up this map of Tanzania, we can already see the shape of Tanzania. So that's how we know we're looking at the right country. So let's just go on to improve this plot slightly. I'm going to set the point size to be a lot smaller. So size equals 0.1 is a parameter that governs the size of the dot. And I'm going to color code it by whether the pump is functional or not. So those are the labels you saw in the second column earlier. So right now I should get another plot, slightly better looking, with smaller dots, and there you go. Color-coded dots based on if they're functional or not. So you can see it's already interesting. We can see areas where there are a lot of functional pumps and some areas where there's a high concentration of non-functional pumps. So the second part of this task is to make a model. And so since we don't have enough time to really cover the mechanics of making a machine learning model like this, for this demonstration, I'm just going to kind of go through it, but I'll put all this code up on GitHub later in case any of you are interested. You can check it out. So let me just pull it up really quick. Okay. So for those of you that have taken a data mining or a stats class, you might be familiar or have heard of this algorithm called random forest. The algorithm that I'm using today is called XGBOOST, and it's very similar to random forest in that it's an ensemble tree learning model. So don't worry if that doesn't mean anything to you, because you'll still get to see the process of how training a model looks and also the results of our model. So I'm going to start training our model right now. And so this is what it looks like when it's training a model. A lot of machine learning models are iterative, so it's going through this step by step and improving on the previous step with each iteration. So since I've set this to run for about 1,000 iterations, it would take a lot longer than 5 minutes, I'm going to pop out with the magic of video editing, and I'll be back in a second once it's done. All right, and we're back. So it took about 5 minutes for our model to go through 1,000 iterations, and the optimal classification rate it gets at the end is 82.1%. So considering that the original split between non-functional and functional pumps was around 50%, that's actually a really great improvement for the short amount of work that we put into it. And there you have it. That's what training a machine learning model looks like in R. If you'd like to take a closer look at the materials I used for this demo, I put all the code and some examples up on GitHub. Here's the link. If you follow the link, you'll get to my GitHub. And here you'll find all the materials I used for the demo. You'll find my DataViz demo here, as well as the XGBOOST demo. I've also included links to the dataset and the competition, and information about ggplot2 and XGBOOST. So if you want to learn more, check it out. Thanks so much for watching and hope you enjoyed it.